Hello guys, welcome back to the channel Mathemagix JEE. In this session, we are going to discuss 15 derived problems that has been derived from previous 6 shifts of JEE Main 2025. I have linked the question PDF in the description. You have to attempt them in proper time bounded manner. The answer key is also provided, and right now I am going to discuss the solutions of each and every questions in this video. So make sure you attempt those problems before seeing this discussion. So let's begin. Here is the first problem. It says the range of a for which the equation this has no root in the interval e to infinity is what? Okay. So first we have to comment on the roots of this equation. So let us try to simplify this first. We take log both sides with respect to base e. So here it will be log x equal to, it will be log x whole cube plus a divided by 3. That means log x whole cube minus 3 log x plus a equal to 0. Now we have to find the range of a for which this equation has no root in the interval e to infinity. So if we substitute t equal to log x, then we can say that t should belong to the interval 1 to infinity, open 1 to infinity. So from here we can write as t cube minus 3t plus a equal to 0. This equation must not have a solution in interval 1 to infinity. So let us try to plot the graph of this function first. Let us call this ft. So f of t is t cube minus 3t plus a. Now if we check the derivative of this function, f dash t will become 3t square minus 3. So basically 3 into t minus 1, then t plus 1. Now as t belongs to 1 to infinity, we can say that this is always positive, this one, and this one is also positive. So we can clearly say that f of t is strictly increasing in 1 to infinity. Now what does this mean? If we plot a rough graph of this function f of t versus t, then here is the point t equal to 1. Now after t equal to 1, the function is strictly increasing. So if it has no roots in the interval e to infinity, that means the graph of this function must look like this one. Why? Because let us assume that the function looks like something like this. So here the function is increasing. So in the interval 1 to infinity, this function has a solution. This case is not possible. That means if the function has no root in the interval t belongs to 1 to infinity, that is x belongs to e to infinity, then the function must look like this one. So the value of f of t at t equal to 1 must be greater than equal to 0. So what is f of 1? F of 1 is simply a minus 2. So a minus 2 should be greater than equal to 0. So a should belong to 2 to infinity and close bracket in 2. So we can see none of the option matches with this. So option D will be the correct option. I hope you understood the concept behind this question. The next question says that English words with or without meaning are to be formed using 5 distinct letters from the set of all English alphabets such that the middle letter of each word is G. Okay. No two vowels are consecutive. Okay. And all letters are in alphabetical order. So let us understand this situation. Here is a letter of 5 words. The middle letter is G. And there are letters of these words which are in alphabetical order. So that means every letter of this word must be in alphabetical order. Okay. And no two vowels are consecutive. So if all letters are in alphabetical order, that means here if this is the position of G, then if we are to fill the left hand side of G, then we have to choose any two of the letters from A to F. Why? Because if we, let's say, choose H for one of these two places, then the letter will not be in alphabetical order. So here we have to choose any two letters from A to F. And similarly, here we have to choose any two letters from H to Z. Now, the middle letter is G. Okay, this condition is satisfied, this condition is satisfied. Now we have to focus on this condition. No two vowels are consecutive. So basically, we can think it in this way. We are subtracting the number of words where two vowels are consecutive from the total number of words that are possible in this case. So, how many words are possible in this case? Total is equal to, here are how many letters? A, B, C, D, E, F. So, 6. And here are how many letters? There are 19 letters. So we can select two letters out of this six and fill this in only one way. That is the alphabetical order. Similarly, we can select any two of these 19 letters and fill them in only one way. So total number of words that are satisfying these two conditions 1 and 3 are 6c2 into 19c2. So this is equal to 6 into 5 by 2 into 19 into 18 divided by 2, and if we calculate this it will become 15, then this will become 9. So it comes out to be 135 into 19. So 135 into 19 comes out to be 1565. Sorry, this will be 2. So 2565. This is the total number of words that are satisfying condition 1 and condition 3. Now we have to subtract those cases from this total number of words where two vowels are consecutive. So from A to F, how many vowels are there? There are two vowels, A and E. And from H to Z, there are total three vowels, I, O, and U. So there are two vowels, A, E, and there are three vowels, I, O, and U. So for the words that have two vowels as consecutive letters, we can determine by filling these places by these vowels. So we can denote the total number of words where two vowels are consecutive as number of either these two places have two consecutive vowels or these two places have two consecutive vowels. So either left or right. So this, according to the set theory, will become n of L plus n of R minus n of L intersection R. Now what will be number of L? So n of L will be basically the number of ways in which we can fill up these two places using these two vowels such that the two vowels are consecutive. So there is only one case here for this left hand side, but for each and every case of this left hand side, we can fill up this right hand side in exactly 19 C2 ways, because here are 19 letters and we choose any two of them, then we fill this and the left hand side is fixed, which is A and E. So n of L becomes 1 into 19 C2. Similarly, n of R will become, if we choose any two vowels of these three vowels, so 3C2, then we can select any two of these six letters to fill up this left hand side. So it will become 6C2. Now L intersection R. So L intersection R, we can easily see that A, E is the only case possible in the left hand side, but in the right hand side, there are 3C2 possible ways. So it will be 3C2. into 1. So n L union R comes out to be 19C2 plus this will be 3C2 times 6C2 minus this will be 3C2. So this comes out to be 19 times 9 plus this will be 3 into 15, so 45. This will be 3. So this is, I think, 190 minus 19, which is 171, plus this is 42. So 3 and 2, 1. So now we have to subtract this from these cases. So the actual number of words which are satisfying all the three conditions is 2565 minus 213. That is 2, then 5, then 23. So 2352 is the correct answer for this problem. I hope you understood the concept behind this problem. Now the next question says that let Sn equal to 1 plus 1 plus 4 plus 1 plus 4 plus 9 plus this up to n terms. Then we are to calculate limit n tending to infinity sigma r plus 1 divided by Sr, where r runs from 1 to n. Okay. So first we have to calculate this Sn first. So Sn is basically T1 plus T2 plus so on up to Tn, where T1 is equal to 1, T2 is equal to 1 plus 4, T3 is equal to 1 plus 4 plus 9, and so on. So we can say by observing the pattern that T1 is equal to 1 square, T2 equal to 1 square plus 2 square, and so on. TR will be 1 square plus 2 square plus so on up to R square. Basically, the sum of squares of first R natural numbers. So we know that this is a direct formula which is equal to R into R plus 1 into 2R plus 1 divided by 6. So TR will be R into R plus 1 times 2R plus 1 divided by 6. Now TR is this, so Sn will be summation TR from R equal to 1 to n. This will be equal to summation R equal to 1 to n. Now this will be 1 by 6 we can take outside, and then if we multiply this, it will become R square plus R times 2R plus 1. So this becomes 1 by 6 summation R equal to 1 to n, then 2R cube plus 2R square plus R square, so 3R square plus R. Now we need to solve this sigma. So this will be equal to Sn equal to 1 by 6, then summation R cube we know as n into n plus 1 by 2 and whole square of it. So it will become 2 times n square times n plus 1 whole square divided by 4. Now plus, then it will be 3 times summation R square. So 3 times n into n plus 1 divided by 6 into 2n plus 1, plus this will be summation R. So it will be equal to n into n plus 1 divided by 2. So Sn will be equal to 1 by 6. Then we can take this n into n plus 1 common. So n into n plus 1. Then we can also cancel this. So we will get a 2 outside here. Then inside this bracket will be n square plus n, plus this will be 2n plus 1, and this will be 1. So it becomes n into n plus 1 divided by 12 times this will be n square plus 3n plus 2. Or we can factorize this as n plus 2 times n plus 1. Now Sn is calculated as this. So we are to calculate limit n tending to infinity summation R plus 1 divided by Sr. So R plus 1 divided by Sr with a summation running from R equal to 1 to n will be equal to summation R equal to 1 to n, then R plus 1, then divided by Sn. So Sn will be 12 outside, then R into R plus 1, then R plus 2, then R plus 1. So we can see as R varies from 1 to n, this can be cancelled. So it becomes 12, then summation running from 1 to n, then 1 upon r into r plus 1 times r plus 2. Now this is a telescopic series here. So we multiply and divide by 2 so that we can write this 2 as r plus 2 minus r. So this series will become 6 times summation r equal to 1 to n. Then it will become 1 over r into r plus 1 minus 1 over r plus 1 times r plus 2. Now, if we put r equal to 1 to n, it will become 6 outside. So, this will become 1 divided by 1 into 2 minus 1 divided by 2 into 3 plus 1 divided by 2 into 3 minus 1 divided by 3 into 4 and plus so on up to 1 divided by n into n plus 1 minus 1 divided by n plus 1 into n plus 2. Now we can observe easily that these terms will get cancelled with each other. And if we tend the limit n towards infinity, then we will get limit n tending to infinity summation r equal to 1 to n r plus 1 divided by sr is equal to 6 divided by 1 into 2. So basically 3. So 3 will be the correct answer for this question. I hope you understood this question. Let's proceed. The next question says that let the ellipse E2 be the mirror image of the ellipse this about the line this. Okay. So we are given a ellipse here. Let us say this is the coordinate axis and this ellipse looks like this. So these are the points. This is 5 comma 0. This is minus 5 comma 0. This is 0 comma minus 4 and this is 0 comma 4. E2 is the mirror image of this ellipse. This is ellipse E1 and the mirror image of this ellipse about the line 4x minus 5y minus 20 equal to 0 is E2. Now what is this line? If we try to plot this line, it will be, if we put y equal to 0, x comes out to be 5, and if we put x equal to 0, y comes out to be minus 4. So basically, the line passes through the points 5 comma 0 and 0 comma minus 4. So we can see the line passes through the ends of major axis and minor axis of this ellipse. So this is the line L. And E2 is the mirror image of this ellipse about this line. So the mirror image will look something like this. Let's say. Maybe we can draw it a little bit clearer. So the mirror image will look something like this. This is a rough diagram. Okay. So now we are to calculate A1 and A2, where A1 is the area of the region that is inside E1 but outside E2. Okay. So this is ellipse E1, this is ellipse E2. A1 is the area of the region that is inside E1, okay, but outside E2. So A1 is this region and A2 is the region that is inside E2 but outside E1. So this region. This is our A2, this is our A1. Then we are asked to calculate the sum of A1 and A2. So how can we calculate these areas? So as this ellipse E1 is mirror image of this ellipse E2 about this line L, we can say by symmetry A1 should be equal to A2. So sum of A1 and A2 will be simply 2 times A1. So if we can somehow calculate this A1, then we can find the sum of A1 and A2. Now how to find this A1? So from this graph, we can say that A1 is basically the total area of the ellipse, that is pi times semi-major axis times semi-minor axis. So semi-major axis is 5 and semi-minor axis is equal to 4. So it becomes 5 into 4 times pi minus this total region, this region. Now what will be this region? This region we can again say by symmetry. This region, let's say the area of this region is small a, so small a will be 2 times the area of each of these areas. So 2 times this. Now we can say that as E2 is the mirror image of the ellipse E1 about this line, so 5 comma 0 will also be a end of major axis for ellipse E2. And similarly 0 comma minus 4 will also be a end of minor axis of ellipse E2. So this yellow area we can calculate easily as 1 by 4 of total area of this ellipse E2, which is pi times this 5 comma 4, sorry, 5 into 4, then minus the area of this triangle, this triangle. So the area of this triangle will be equal to half times 5 into 4, and our small a will be 2 times this area. So 2 times this is equal to 20 pi divided by 4 minus 20 divided by 2. So a1 is basically pi into 5 into 4 minus this small a. So a1 will be 20 pi minus this will be, if we calculate small a, 20 pi divided by 2 minus this will be 20. So it comes out to be, this will be 10. So 10 pi plus 20. So it becomes 10 into pi plus 2. This is the value of a1. Now we have to calculate 2a1. So 2a1 we can multiply by 2. It becomes 20 into pi plus 2. This is our answer. That means option A will be the correct option for this question. I hope you understood the concept that has been used in this question. The next question says that if z is a complex number satisfying modulus of z minus 4 plus 7 iota is less than equal to 2, then the difference between the largest and the smallest inclinations of the line joining origin and z is what? Now, note this term inclination. What does this mean? It means if this is a straight line in xy plane, then the angle that the straight line makes with the positive x-axis is termed as the inclination of that line, or simply the angle of inclination, which is denoted as theta. And gradient is basically tangent of the angle of inclination. So we have to calculate the difference between the largest and the smallest inclinations. Okay. So let us draw the diagram first. Now we know that this locus is basically a circle in complex plane. So let us say this is our coordinate axis and this is the point 4 comma 7. Now it is a circle of radius 2 units, so this will be like this, and here is the origin, which is 0 comma 0. Now we know that the largest inclination will be in case of the largest slope and smallest inclination will be in the case of smallest slope, because the circle is in first quadrant, and therefore if theta is greater, that means tan theta will also be greater. So if we draw the tangents to this circle from this origin, two tangents can be drawn to this circle from origin. So this will correspond to the minimum slope or minimum inclination. Let us say this as theta 1, and this will correspond to the maximum slope or maximum inclination, which is, let's say, theta 2. So we have to calculate the difference between them. So basically we have to calculate this angle. Now how to calculate this theta? If we join the center of this circle to the origin, we can say that both of this angle will be equal to theta by 2 because of the property of circles. Now what will be the value of tan theta by 2? Tan theta by 2 will be simply perpendicular upon base, because this is a right angle triangle. So perpendicular is radius of this circle, which is 2, and base is basically the length of tangent of this circle from the point 0 comma 0. So if we calculate length of tangent, it will be x minus 4 whole square plus y minus 7 whole square minus 4 under root with xy equal to 0 comma 0. So the length of tangent will be equal to 16 plus 49 minus 4, which comes out to be root under 61. So it will be root under 61. Now from here we can easily calculate tan of theta by using trigonometry. So tan of theta will be 2 tan theta by 2 divided by 1 minus tan square theta by 2, which is 2 into 2 by root 61 divided by 1 minus 4 by 61. So if we calculate this, it becomes 4 by root 61 times, this will be 57, sorry, this will be in the denominator. So 57 and this will be 61. Now if we simplify further, it becomes 4 root 61 divided by 57. Now if tan theta is equal to this, can we directly say that theta is tan inverse this? No, we cannot always say that. How? Let us see. So let's say this is a circle. Okay, this is the center of this circle, and here is the director circle of this circle. Director circle is locus of all the points where the perpendicular tangents of a circle meet. So we know the radius of the director circle in case of a circle is equal to root 2 times the radius of the original circle. So if this is the circle, let's say x minus 4 whole square plus y minus 7 whole square equal to 4, which is given to us in the problem, then the director circle will be x minus 4 whole square plus y minus 7 whole square equal to 8. Now observe a beautiful thing, that from any point on this director circle, if we draw two tangents to this circle, the angle between tangents is always 90 degree. But if we lie between the boundary of this inner circle and the boundary of the outer circle, let's say this point, then if we draw two tangents to this circle from this point, then the angle between those two tangents will be greater than 90 degree. And if we go out of the boundary of this outer circle, let's say here, and we draw two tangents to this inner circle from this point, the angle between those two tangents will be less than 90 degree. Now if we see this particular case which is given to us in this problem, this 0 comma 0 lies outside the director circle of this circle, because you can check by putting 0 comma 0 in this equation. You will get this x minus 4 whole square plus y minus 7 whole square minus 8 is greater than 0. That means the point lies outside the circle. So we can say the angle between those tangents drawn from the origin to this circle must be acute angle. If theta is an acute angle, we can say by the principal domain of inverse trigonometric functions that tan inverse of tan theta will be simply theta. So we can directly apply tan inverse here. So theta will be equal to tan inverse, this was 4 root 61 divided by 57. Now if we try to match the options, none of the options matches with this. So we have to try to convert this into sine inverse or cos inverse. So let us try. So if we try to draw the triangle first, this is 4 root 61, this is 57, and this is the hypotenuse. Now hypotenuse will be root under, this will be 16 times 61 plus 57 square. Now if you calculate this value, it comes out to be 65. So it will be 65. So we can say that theta will be sine inverse 4 root 61 divided by 65, or theta is equal to cos inverse 57 upon 65. So we can clearly see in the options, option D will be the correct option in this case. I hope you understood the concept that has been applied in this question. The next question says that geometric progressions with positive common ratio are formed using the set of first 4096 natural numbers, okay, such that first terms of all the progressions are 1 and the last terms are 4096. Then sum of all possible common ratios of such geometric progressions is what? Okay. So let us say the nth term of this GP is 4096 and the first term is 1 and the common ratio is R. Okay. So we know 1 into R to the power n minus 1 should be 4096. Now this can be written as R to the power n minus 1 is equal to 2 to the power 12. Now if we take log both sides with respect to the base 2, we get n minus 1 into log r base 2 is equal to 12, or n equal to 1 plus 12 upon log r base 2. So now we can observe that number of terms here in the left hand side should be an integer. That means the right hand side should also be an integer. That means 12 upon log r base 2 should also be an integer. So log r base 2 should be a factor of 12. That means log r base 2 can take values 1, 2, 3, 4, 6 and 12. So from here we can say r can take values 2 to the power 1, so 2, 2 square, so 4, 2 cube, so 8, 2 to the power 4, so 16, then 2 to the power 6, that is 64, and 2 to the power 12, that is 4096. So these are the possible common ratios of such geometric progressions. Now we have to simply sum up all of this. So if we sum up all this, so it becomes 4096 plus 64 plus this becomes 30. So this becomes 4096 plus 94. This becomes 4100 plus 90. So 4190. 4190 is the correct answer for this question. The next question says that if A, B, C are three non-singular 3 by 3 square matrices such that this holds true, this holds true, and this holds true, okay, then square of the determinant of the matrix adjoint of 2A inverse is 2 to the power m. We have to find the value of m. So here the first equation is determinant C adjoint of adjoint C is equal to minus 243. Now we can use the property of determinants to split this. So it will be determinant of C times determinant of adjoint C is equal to minus 243. Now determinant of adjoint C we can write as determinant C whole to the power 4. So this will be determinant C whole to the power 5 is equal to minus 243 we can write as minus 3 whole to the power 5. So determinant C comes out to be minus 3. Similarly, if we consider this second equation, we get determinant of B adjoint of B inverse is equal to 1 by 18. Now again we can use the properties of determinant. So this will be determinant B times determinant of adjoint of B inverse will be simply determinant of adjoint B whole inverse. It is equal to 1 by 18. Now this one we can again write as 1 by determinant of adjoint of B. And determinant of adjoint of B will be simply determinant B square, because B is a 3 by 3 square matrix. So this gives us determinant B equal to 18. Now, if we use the third relation here, we take determinant both sides. Determinant of adjoint C will be equal to determinant B times determinant of adjoint A. So we can write this determinant of adjoint A as determinant A whole to the power 4. So determinant of A whole to the power 4 will be simply determinant of adjoint C is determinant C square divided by this will be determinant of B. So this comes out to be 9 over 80. So 1 by 2. Now we are to calculate the square of the determinant of the matrix adjoint of 2A inverse. So determinant adjoint of 2A inverse square. Now we can use the properties of adjoint and determinant to calculate this. We know adjoint of Km is k to the power n minus 1 times adjoint M, where n is the order of the matrix M. So this will give us 2 to the power 2 adjoint of A inverse and then determinant square. Now if we want to pull out this 2 square out of this determinant, we have to raise it to the power 3, and 2 here or the square here we have to again raise this to the power 2. So this will be this times determinant of adjoint A inverse square. Now this will be equal to adjoint of A whole inverse and then determinant square. So basically it becomes 1 over determinant of adjoint A whole square, which becomes 1 by determinant A whole square to the power 2. So determinant A whole to the power 4. Now determinant A whole to the power 4 we calculated already, it is equal to half. So this will become 2 to the power 1 times this. So this is 2 to the power 4 into 3. So 2 to the power 12. That means the final answer comes out to be 2 to the power 13. So on comparing, we can say the value of M will be simply 13. I hope you understood this question. Let's proceed to the next question. The next question says that total number of irrational terms in the expansion of this is what? So we can write the general term of this expansion, which is 10 factorial upon p factorial, q factorial, r factorial, then 1 to the power q, 4 to the power 1 by 4 whole to the power q, then 9 to the power 1 by 9 whole to the power r, where this p plus q plus r is equal to 10. Now be careful while handling these terms, because this 4 and 9 both are composite numbers. So we have to first convert them into primes. So it will be 1 to the power p, then 2 to the power q by 2, then 3 to the power 2r by 9. Then this coefficients as it is. So if we are to calculate the number of irrational terms, we can say that number of irrational terms will be total number of terms minus total number of rational terms. So total number of terms is known to us, which is 10 plus 3 minus 1, so 2c2, that is 12c2. Now we have to calculate number of rational terms in this expansion and then subtract them. Now we can say by this general term that terms will be rational when q will be a multiple of 2 and r will be multiple of 9. So q can be equal to 0, 2, 4, 6, 10, because all of this P, Q, R varies from 0 to 10. Similarly, R can take 0 and 9, these two values, and P can be anything. So 0, 1, 2, so on up to 10. Now we have to consider the different combinations of P, Q and R. So let us make a table here, P, Q, R. So let us try to make the combinations. Let us take P equal to 0. As P, Q, R, their sum has to be 10, this condition. So we can say that Q plus R should be 10. Now let us put Q equal to 0. Then R should be 10. But that case is not possible. So we reject this case. Now let us put Q equal to 2. This case corresponds to R equal to 8, which is also not possible. So let us also reject this case. Now, as the number of variables in R is less, so let us try to put R equal to 0. So Q must be equal to 10, which also satisfies the given conditions. So this is a possible case. Okay. Now let us try to put R equal to 9. That case will not be possible because then Q have to be 1. So we reject that. Now let us try to put Q equal to 8. So Q equal to 8 and P plus R should be equal to 2. As R can be only 0 and 9, so let us put R equal to 0. So P should be 2. Then let us put Q equal to 6. Then we get P plus R equal to 4. So R should be 0 and P should be 4. Similarly, let us take Q equal to 4. So Q equal to 4 means P plus R should be 6. So R is 0 and P is 6. Similarly, Q equal to 2, then R should be 0 and P should be 8. And then Q equal to 0, then P plus R should be 10. So we have two different combinations, that is this and then 0, then 9 and 1. So there are altogether 7 cases possible. So rational terms are 7 in this expansion. So total number of irrational terms in this expansion will be 12C2. So 12 into 11 divided by 2 minus 7. So this will be 66 minus 7 will give us 59. So 59 is the correct answer for this question. I hope you understood this question. The next question says that consider the branch of the hyperbola, this lying in the first quadrant. Okay. So here is the hyperbola, and we have to consider only that branch which is lying in the first quadrant, like this. This is the point a comma 0. If the area bounded by the hyperbola coordinate axis and the line y equal to 2 is this, then the eccentricity of the conjugate hyperbola of h is what? So we know, to find the eccentricity of the conjugate hyperbola, we have to find the eccentricity of this hyperbola h first. For that, we have to find the value of this a. So a we can find using this information. So let us say this is the line y equal to 2 here. So the area bounded by them will be this. This is the hyperbola h, and this area we can easily calculate. It will be a equal to, from y equal to 0 to y equal to 2, x is we can say a root under 1 plus y square by 2, or a by root 2 root under 2 plus y square. So it will be a by root 2, then 2 plus y square under root dy. So we can easily calculate this. It will be using the formula root under a square plus x square dx integral. We can say that it will be equal to y by 2 root under a square plus y square plus a square by 2, which is 2 by 2, root under, sorry, log, then modulus y plus root under 2 plus y square, and then limits from 0 to 2. So this is equal to a by 2 root 2, and if we put the limits, it will be, this will be 2 root 6 plus this will be log of 2 plus root 6, and then if we put limit 0, it will be 0, and this will be log root 2. So this comes out to be a by 2 root 2, then 2 root 6 plus this will be log root 2 plus root 3. Sorry, there will be a 2 here. So 2 times this, or we can say it will be equal to, if we take this 2 inside, it will be log root 2 plus root 3 whole square, that is equal to 5 plus 2 root 6. Now this area is equal to, according to the question, 2 root 6 plus log of 5 plus 2 root 6. So we can say that they will cancel each other. So a comes out to be 2 root 2. So the eccentricity of this hyperbola is equal to 1 plus b square by a square under root. So it will be 1 plus b square is 2 and a square is 2 root 2 whole square, so 8. So it comes out to be root under 5 by 4 or root 5 by 2. This is the eccentricity of this hyperbola H. Now we have to calculate the eccentricity of the conjugate hyperbola. So we know if E dash is the eccentricity of conjugate hyperbola, then 1 by E dash square plus 1 by E square is equal to 1. So from here we can say that 1 by E dash square will be 1 minus 1 by E square is 4 by 5. So 1 by 5. So E dash comes out to be root 5. So our correct option in this case will be option number C. I hope you understood this question. The next question says that if the function fx equal to this is defined for all x belonging to alpha to infinity, then the least possible value of alpha is what? Okay. So basically we have to find the domain of this function fx. So we know as this whole thing is inside log function, so this whole thing should be positive. So we can say x to the power 7 minus 7x to the power 6 plus 21 x to the power 5 minus 35 x to the power 4 plus 35 x cube minus 21 x square plus 7x minus 1 divided by, this is x to the power 4 minus 2x cube plus 3x square, then minus 2x plus 2. It should be greater than 0. Now we have to comment on x. So now we can observe a beautiful thing here, that this whole numerator is nothing but the expansion of x minus 1 whole to the power 7. How? This 7 can be written as 7c1. This 21 can be written as 7c2, which is 7 into 6 divided by 2, which is 21. Then this 35 can be written as 7c3. And then again, this can be written as 7c3 or equivalently 7c4. This can be written as 7c5. This can be written as 7c6. Then it is 7c7. So if you expand this x minus 1 whole to the power 7, you will get the exact same expression as the numerator. So this numerator is sorted, x minus 1 whole to the power 7. Now comes the denominator. What is this? So we can say it is not the expansion of any binomial expansion. So let us try to interpret this thing separately. X to the power 4 minus 2x cube plus 3x square minus 2x plus 2. Now here we have to keep in mind, whenever we see symmetric coefficients, like here is 1, then minus 2, then 3, then again minus 2, then it should be 1. So let us break this 2 into 1 plus 1. So we can simplify this part first. So it can be written as x to the power 4 minus 2x cube plus 3x squared minus 2x plus 1 plus 1. Now this part we can divide and multiply by x square. So it becomes x square, then it becomes x square minus 2x plus 3 minus 2 by x plus 1 by x square plus 1. And obviously, as we divided and multiplied by x square, x should not be equal to 0. So x not equal to 0. Now here, if we arrange these terms, we can pair this term and this term. So we get x square plus 1 by x square, then minus 2 times x plus 1 by x plus 3. Now this we can again represent as x plus 1 by x whole square minus 2. So it becomes overall x square outside, then inside this bracket x plus 1 by x whole square minus 2 times x plus 1 by x, then plus 1. So this can be factorized as x square, then x plus 1 by x minus 1 whole square plus 1. Now this denominator is this, and for this to hold true, x should not be equal to 0. So we can say the denominator is always positive because this is some square and this is plus 1. So this denominator is always positive, so we don't have to consider its sign. So our inequality becomes x minus 1 whole to the power 7 is greater than 0. So from here we get x should be greater than 1. And this also satisfies our condition that x not equal to 0 because x is greater than 1. So x should belong to the interval 1 to infinity. So here the least possible value of alpha will be 1. Option B will be the correct option for this question. I hope you understood the concept behind this question. The next question says that let fx be this, where x lies between 0 and pi by 2. Then the value of f of 1 by 10 plus f of 1 is what? So let us first decode this fx. So it is something of the form sine inverse a cos x plus b sin x. So let us put this equal to sine alpha. Now if you draw the triangle, you can see that it will be equal to cos alpha, where alpha is tan inverse 56 by 33. So our fx comes out to be sine inverse this sine alpha cos x plus cos alpha sin x. So sine of x plus alpha. Now we have to find a range of alpha because sine inverse sine theta is not always theta. The value of sine inverse sine theta depends upon the quadrant where theta is lying. So x lies between 0 to pi by 2 and alpha we have to find. So we can say that this is nearly equal to tan inverse. If we divide 56 by 33, it is approximately 1, then it is approximately 7. So tan inverse 1.7 approximately. This is less than tan inverse root 3 because root 3 is 1.732 and this is 1.7. So this alpha should be definitely less than pi by 3. And alpha should also be greater than pi by 4 because tan inverse 1 is pi by 4 and this is definitely greater than 1. So alpha lies between pi by 4 to pi by 3. So x plus alpha should lie between pi by 4 and this will be 5 pi divided by 6. Now as x plus alpha belongs to this range, we have to break this function fx into two intervals, because sine inverse sine theta will be theta when theta lies in the principal domain, and will be pi minus theta when theta lies between pi by 2 to pi. So fx will be equal to x plus alpha when this x plus alpha lies between 0 to pi by 2, or we can say pi by 4 to pi by 2, and it will be equal to pi minus x plus alpha when it lies between pi by 2 to 5 pi by 6. Now we have to find the value of f of 1 by 10. So we can say from here that alpha lies between pi by 4 is approximately 0.78, and pi by 3 is approximately 1.05. So if we put x equal to zero point 0.1, this becomes zero point 0.1 plus alpha lies between 1.15, sorry, 0.88 and 1.15. Now this pi by 4 is again 0.78 approximately, and pi by 2 is approximately 1.57. So zero point 0.1 plus alpha, or equivalently x plus alpha when x equal to zero point 0.1, lies between these numbers 0.78 and 1.57. So we can say f of 1 by 10 will be equal to 1 by 10 plus alpha. Now let us consider this case f of 1. So we can say as alpha lies in this interval, so 1 plus alpha should lie between, this is 1.78 and this is 2.05. Now pi by 2 is again approximately 1.57, and 5 pi by 6 is approximately 5 into 0.52, which is approximately 2.6. So this 1 plus alpha lies between 1.57 and 2.6. So we have to take this case. So f of 1 will be pi minus 1 plus alpha. So pi minus 1 minus alpha. So their sum, if we calculate, we get it will be equal to pi minus 1 plus zero point 0.1. So overall pi minus zero point 0.9. So pi minus 0.9 is the final answer to this question. So option D will be the correct option. So keep in mind that you have to always check whether this theta lies in the principal domain or not. Otherwise your question will be wrong. Let us proceed to the next question. The next question says that let A, B, C be three vertices of a triangle inscribed in the ellipse this, okay, such that all of the vertices are equidistant from the point 2, 0. So we can say for the triangle ABC, this is the circumcenter. Let us denote this by O. If the orthocenter of the triangle ABC bisects the chord 9x plus 15y equal to 29, then we are to calculate the sum of x coordinates of the points A, B and C. So we can find the sum of x coordinates if we know the coordinates of the centroid of this triangle. So for the coordinates of the centroid, we need to find the orthocenter first, because then we can use the Euler's line, which is the relation between orthocenter, circumcenter and centroid. We can then derive the coordinates of this centroid G. Now we are given that orthocenter of the triangle ABC bisects the chord 9x plus 15y equal to 29. So basically orthocenter is the midpoint of this chord. Now how to write the equation of a chord of a conic with a given midpoint? We have to simply use t equal to s1. So t will be x1 by 5 plus y1 by 4 minus 1. It is equal to s1 will be x1 square by 5 plus y1 square by 4 minus 1. So from here this 1 gets cancelled, and this is the equation of the chord. Now we compare with the given chord. So x1 by 5 into 9 should be equal to y1 by 4 into 15 should be equal to x1 square by 5 plus y1 square by 4 divided by 29. Let us say all these are equal to some non-zero constant k. So x1 will be 45k, y1 will be 60k, and from here, if you solve these equations, you will get the value of x1 equal to 1 and y1 equal to 4 by 3. x1, y1 is the coordinates of the orthocenter of this triangle ABC. So we know that coordinates of h, which is 1 comma 4 by 3. Now 2 comma 0 is the circumcenter, so we can easily find the centroid because we know the centroid divides the line joining orthocenter and circumcenter in the ratio 2 is to 1. So 2 is to 1. So the coordinates of G will be 2 times 2 plus 1, so 5 by 3. Then it will be 2 times 0 plus 4 by 3 by 3. So 4 by 9. Now as G is the centroid of this triangle, so we can say summation xi divided by 3 should be equal to 5 by 3. So summation xi, or the sum of x coordinates of all these points a, b, c, comes out to be 5. So 5 is the correct answer for this question. I hope you understood this question. The next question says that if this integral equal to alpha times this integral, then the value of 31,200 times alpha is equal to what? Okay. So if we have to compare these two integrals, let us first make this limits same. So in the first integral, we substitute t equal to 2x. So dt will become 2 dx. So the first integral becomes 0 to 1 integral 1 minus t to the power 10 whole to the power 25 dt times half equal to alpha times this second integral. Now in this integral, if we want to convert this into this format, we can use a substitution x equal to t square. So dx will be 2t dt. So it will become integral 0 to 1, then t to the power minus 1, then 1 minus t to the power 10 whole to the power 27, then 2t dt. So the right hand side will become alpha times integral 0 to 1, then this will cancel. So 1 minus t to the power 10 whole to the power 27 dt times a 2. So we can say from here that alpha is 1 by 4 integral 0 to 1 1 minus t to the power 10 whole to the power 25 dt divided by integral 0 to 1 1 minus t to the power 10 whole to the power 27 dt. Now this format is known to us. Why? Because we know if I of r comma n is 1 minus x to the power r whole to the power n integral from 0 to 1, then this is nothing but 1 by 4 times I of 10 comma 25 divided by I of 10 comma 27. So we have to calculate this value. Now we can say I of 10 comma 25 divided by I of 10 comma 26 is equal to 1 plus 1 by 10 into 26. And similarly, I of 10 comma 26 divided by I of 10 comma 27 is equal to 1 plus 1 by 10 into 27. So if we multiply these two, then we get I of 10 comma 25 divided by I of 10 comma 27 is equal to, this will be 261 divided by 260 times 271 divided by 270. So our alpha will be 1 by 4 times this. So 1 by 4. So 31,200 times alpha will be multiplied by 31,200 here. So if we calculate this whole quantity here, this can be cancelled. So 4 sevens are 28 and 4 is a 32. Then it will be 3 and then it will be 9 and then it will be 9 to the 18 and 9 is the 81. So it becomes 271 times 29. So it becomes 924. Then 542. So it becomes 5, then 8, then 7. So the value of this quantity is equal to 7859. This is the answer of this question. I hope you understood the concept behind this question. Now, the next problem says that let gx equal to minimum of these functions and hx equal to maximum of these functions for all x belonging to closed 0 to 15. Then which of the following statements is not true? Okay. So we have to check all these statements. First, let us draw the graphs of these functions. Now, to draw the graph of these functions, let us quickly note some interesting points. So here point 1 is if we are to calculate the intersection points of two graphs, modulus of x minus a and modulus of x minus b, then their intersection point will always be equal to the arithmetic mean of this a and b. So a plus b by 2. So at x equal to a plus b by 2, they will intersect. And the second point is the y coordinate at the intersection point x equal to a plus b by 2 will be always equal to modulus of a minus b divided by 2. So these points you have to keep in mind while drawing these graphs of these modulus functions. So let us try to plot the graphs of these two functions. So here is our coordinate axis. Now this is the point 1, this is 3, this is 6, this is 10 and this is 15. So 1, 3, 6, 10, 15. So graph of modulus functions will look like this. And the domain belongs to closed 0 to 15. So we have to draw this parts only. So the graphs will look like this. So we can say this intersection point will be x equal to 3 plus 1 by 2, so 2. This will be x equal to 3 plus 6 by 2, so x equal to 4.5. This will be x equal to 8. This will be x equal to 12.5. So gx is the minimum of all these functions. So basically this graph. Now let us calculate the functional values at these points. So at x equal to 2, it will be 3 minus 1 divided by 2, so 1. Here it will be 6 minus 3 divided by 2, so 1.5. Here it will be 10 minus 6 divided by 2, so 2. Here it will be 15 minus 10 divided by 2, so 2.5. So we can clearly see that this is the graph of y equal to gx. So the maximum value of gx will be attained at x equal to 12.5 and the maximum value of gx will be 2.5. So option A is true. Now we have to check the rest of the options. Here it is saying gx is non-differentiable at 8 points. Okay. So as x belongs to close 0 to 15, gx is not differentiable at this point, 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 this point. So total 1, 2, 3, 4, 5, 6, 7, 8 points. So gx is not differentiable at 8 points. So the second statement is also correct. Now let us check the third statement. So to check the third statement, we have to draw the graph of hx. So we can clearly say by this graph that the graph of hx will be obtained by drawing this graph again. Now let us draw this graph of hx. So here it will be 0, it will be 1, this will be 3, this will be 6, this will be 10, this will be 15. And here will be the first graph, then this, then this, then this, and then this one. So we can clearly see the maximum of all these graphs will be this part. So this is the graph of y equal to h of x. So here at this point, the graphs of x minus 1 modulus and modulus of x minus 15 intersects. So their intersection point will have the x coordinate, x equal to 15 plus 1 divided by 2, so 8. And the functional value at this point will be 15 minus 1 divided by 2, so 7. So we can clearly see the minimum value of hx will be 7. So this statement is also correct. So none of this option is not true. That means option D will be the correct option for this question. So this is the last question of this problem sheet. It says triangles are formed using the vertices of a regular n-sided polygon. Okay. If the probability that the triangle is a right angle triangle is 3 by 17, then the number of diagonals of the polygon is what? So here is a n-sided polygon like this. So there are total n vertices. 1, 2, 3, 4, 5 up to this n. We pick randomly 3 vertices and form a triangle. Now we have to calculate the probability that the triangle is a right angle triangle. So to understand this case better, let us take a simple case, n equal to 6. Let us take this example first. So as it is a regular polygon, so it will look something like this. Now here will be the center of the circle passing through all of the vertices of this regular hexagon. So we can say as these 2 points are opposite to each other, so if we join them, then this will be the diameter of this circle. Then among the rest of the points, if we choose any of those 4 points here, let's say we choose this point, then if we join this point with this and this point with this, we will get a right angle, because we know angle subtended by the diameter of the circle is always 90 degree. So here we can say that if n is even, then right angle triangles can be formed in this way. Now you have to keep in mind that whenever you are selecting this vertex, let's say, then you are getting this triangle. But think of an other case where you are selecting this vertex, so this vertex is opposite to it, so it automatically gets selected, and then you are selecting this vertex. So that case is basically the same as the previous one. So basically you are counting each case twice. So we have to also divide by 2 to get the total number of ways. So for a general n, where n is an even number, we get that we select any random vertex of this n vertices. And then from the remaining n minus 2 vertices, we select one vertex and then divide by 2 because we are counting each case twice. So this is the total number of possible ways where a right angle triangle is being formed. Now in the denominator it will be simply NC3, total number of triangles that can be formed using the vertices of a n-sided polygon. So this, if we calculate, this will be the probability. So it will be n into n minus 2 divided by 2. Then it will be n into n minus 1 into n minus 2 into 6. So it becomes 3 by n minus 1. So 3 by n minus 1 according to the question is equal to 3 by 17. So the value of n comes out to be 18. So the polygon is a 18-sided regular polygon. Now the total number of diagonals of the polygon will be simply nc2 minus n. So it will be 18c2 minus 18. So it becomes 18 times 17 by 2 minus 18. So this becomes 153 minus 18. This becomes 5 and this becomes 13. So 135 is the correct answer for this question. I hope you understood this question. So we are finished with this problem sheet. Do comment your favorite question among all these 15 problems and also make sure you practice these questions, especially those who are having exams in the upcoming shifts of JEE Main. Wish you all the best.